Cool. Let's get started. How to systemically test large language models. Thank you again, everyone, for joining. Curiosity here. We've got a really good presentation for you today where you'll learn what it really takes to test LLMs in a smarter, secure, and scalable way. So, getting straight into it, firstly, let me introduce today's speakers and my colleagues, Harry Byrne and Hugh Price. Harry is the Head Solutions Engineer at Curiosity and is a test data management and visual modeling specialist. Since 2020, Harry has worked with the largest global organizations across finance, banking, healthcare, and manufacturing, helping them solve complex data generation, compliance, and quality challenges. With him, we also have our co-founder and chairman, Hugh Price, described as the godfather of test data, although he hates it.
Don't say that. Stop saying it, Mantis. Drives me up the wall.
Every time.
Right.
But he is a serial data inventor and has worked with the world's largest organizations since about 1995, if not even before that, to transform their test data management. And now with Curiosity, he crafts innovative solutions for test data and quality success. So I think without further ado, Hugh, please take it away. I'll just stop screen sharing now.
Good. Okay, so the agenda. We are going to cover an awful lot today. We are pretty much going to be scratching the surface of this massive subject. And at the end, we're going to basically offer you a few options as to some extra stuff we'd like to get into with some follow-up webinars and some practitioner guides, etc. So in a nutshell, also, I am going to talk quite quickly. Now, this is being recorded, so you may decide that you want to go back over this because I'm going to be going at speed because it's such a vast subject. So roughly the agenda breaks down into kind of history of testing, a little bit about that and how that kind of applies to the wonderful world of LLMs and AIs. I'm going to actually just show you our pipeline tool, which has a kind of LLM testing framework in it as well. And that also just will illustrate a couple of different concepts as well. Then we're going to get into the wonderful world of requirements, which kind of, pretty much if you think about it, it's all about the data and the requirements when it comes to LLMs. And Harry is going to, take through a textual requirement and kind of push that through into, a much more rigorous and robust description of what you actually want the LLM to do. I'm going to then carry on a little bit on requirements, and then I'm going to pile into the wonderful world of data, etc. So let's just start with, if you were going to test AI, what were you, probably the first thing you do would be ask AI and say, well, how the hell do I test myself? So this is what AI came up with today. It might be different tomorrow. But if you actually read this, the keywords are unseen, rigorous, and methods. So, AI is smart enough to realize that you need rigor, you need solid methods and approaches, and obviously unseen. Well, how the model forms on unseen data, which is basically new stuff that it doesn't know about or hidden stuff. Now, you can use AI to test AI, absolutely. And a lot of the stuff that we're going to show you today, we use AI. But the asterisk is there really to say if it can be verified. So if you do something with AI, which creates some documentation, for example, and you read the documentation and it's correct, fabulous. But if you're in effect trying to bet the farm on, it approving an invoice or not approving an invoice, that's a totally different kettle of fish, and that's really kind of what we're talking about today. So I'm going to start with a bit of a quiz. It's one of my favorite quizzes. You've probably heard it before if you've heard me ranting on about the poor quality of testing. So you've got 6 switches to turn to A or B. This will arm you've got to turn all 6 switches. This will arm and fire your torpedo. If you get it wrong, you will blow up and everyone will die. So you've got about 10 seconds to work out how many potential combinations are there. Okay, now this is actually a real example and was a problem that the U.S. Navy had because they kept blowing up the torpedoes, and that's where some of the original theory about testing came from. So there is a reason I'm bringing this up. Now the answer is it's about, I don't know, there's about 80 different, it's one of the largest numbers that you could ever imagine. It's an extremely large number. So you've got 6 switches and you've got all those potential variations and combinations that you could do to turn on those 6 switches. Now you look at it and you say, well, it's just 2 to the power of 6, which is 64. However, factorial. Once you add in the order of turning the switches on, then all hell breaks loose. Okay, and if you think about the world that we live in nowadays, things don't arrive in sequence, in sequential order. They're all flying in. You've got messages flying around all over the place, etc. It also illustrates the fact that there's a sort of a thinking out there. Oh, AI is going to solve IT. AI is a bit of a guessing engine. It's looking for coherent patterns, and it's going to try and co-join patterns to come up with new things that could potentially happen. But that's kind of what it is. It could be used to help you work out the number and to solve the problem, but it really isn't kind of the be all and end on anything. If you don't get it right, bang, you blow yourself up and everyone else on the submarine. Now, let's look at testing in the current world. This is the current world that we sort of live in now. Really, the problem in reality is humans are really terrible at dealing with big numbers. The result of this is poor testing and increased costs. It's very easy to say, well, we're just going to hire 2 or 3 more testers and we'll go from 20% coverage to 80% coverage. The reality is that you need almost an infinite number of testers if you're not going to apply systematic and structured approaches and methods, as AI suggests. Now, the results of this, that budgets have grown massively. In some places, 50% of the time can be spent on testing. And as a very wise man once said to me, you just can't test quality into a system. Quality and designing the system actually starts way, way, way at the beginning, and you really have got to make the system testable from the very beginning. Now, the reality is that we are now betting the farm on LLMs using the same types of approaches that we have been using up to now. And I would posit that we haven't done a very good job. So now is the time to rethink. It's green fields. We're for the most part, people are kind of get started here. So this ability to think in a much more structured way is really what we are. One of my hobby horses and now hobby horses within Curiosity. Now, short history of testing. There's lots of different approaches that people have used, and they're all absolutely fantastic, and they all have appropriate methods. White box and black box. White box means that you can basically get inside. It means that you have some kind of code, or you have some kind of logs, or you have some kind of data that you can monitor to be able to see what's going on within there, and that's kind of white box. And then you have black box, which is basically, to a certain extent, some ERPs could be considered black box. They just do stuff. But for the most part, LLMs are black box, but you can sort of look under the covers a little bit to actually use some of these techniques and effects to do that. And actually, some of the stuff we're talking about, requirements, is really going to be talking about that type of stuff. Now, what are the really good ones that can work with black box testing? The first one is a thing called controlled natural languages. And if you look at very, very regulatory or industries where there is, munitions, etc., some healthcare stuff, controlled natural languages have a very small palette of nouns and verbs. And that allows you to be very structured in the way that you actually build things. Now, language is wonderful for poetry. I asked AI to build me a short poem on testing, which it came up with. It did a pretty good job. But actually, if you think about language as a way of expressing requirements, it's actually pretty poor. Open account if the person wants a new mail, or they might want a product, and they might want a product. There's all sorts of things going on in there. So controlled natural languages was a sort of natural growth. Then we moved on to a thing called cause and effect. Richard Bender, good friend of mine in the past. It's very technical. It uses almost logical operators, ors, ands, nands, XNORs, and XORs, but is a very clear way of expressing what you actually want to happen. It's actually great fun. The trouble is, it's really technical and very difficult to get people to actually understand that. But this is a very, very clearly defined mathematical requirement that you can use to build the minimum number of tests to prove decisions and constraints are validated. Now, having worked with Richard Bender, we actually kind of invented the idea of model-based testing in a kind of industrial way with a product called Agile Designer, and now product quality modeler. That's a thing called constraints graphs. It in effect has the same effect as cause and effect modeling, but it's easier to understand and also fundamentally to cooperate, which is kind of what Harry's going to show you in a bit. It also introduced the concepts of observability, and if you look at the 6 switches problem, to make something observable, you put a light on it, and now the problem is if the light isn't working, what happens? So there's a little bit more to it than just chucking lights everywhere. You want to chuck the minimum number of lights that work in combination. Then there's also this thing called testability. And that's really the fundamental problem with IT currently, is that people don't design systems to be testable. And if you think of complexity, the complexity is based on how hard is it to test the system, not the number of lines of code. But coming fundamentally back to it, the advantage of model-based testing is you get a common understanding, and Harry's going to really kind of pile into that a little bit. Now, these techniques are extremely useful for LLM testing. Now, I talked about being able to get under the covers. You can ask the LLM, tell me the methodology you're using and tell me the reasoning that you're doing it. And the examples will show you. That kind of shows you some examples of what the LLM has come back with. And the key point is, did you get the right answer for the right reason? Very often, if you look at white box testing, it will say credit approved, credit disapproved. And actually, there's a bug in there. Sometimes you'll fix that one bug, and what will happen is it will, and suddenly it will expose another 6 bugs, because in effect, a flag has been turned on for the wrong reason. And everyone's being approved, or everyone's not being approved. Okay. Now, this is another interesting one. Did the test work? Possibly, probably, definitely. I asked a testing conference of 500 testers, asked that question, was completely silent for 1 minute. No one had an answer. So in the LLM word, possibly, we ran it before and it gave the same answer. Probably, we ran it before, it gave the same answer, and it gave us a reason to do it. And definitely, we have an external. We've been able to analyze the data, and I'll show you how we do that, to actually calculate that we have definitely got the right answer. So these are the types of concepts you need to think about when it comes to testing. Now, sitting on top of this, you need a testing framework, and the framework is really, you've got packs of data on the left-hand side, you've got tons of requests, you've got you've got to worry about context as well. For the most part, in the demos we're showing, we're fixing the context, we're not moving the context around, and then you've got an evolving set of prompts. APIs, I've lumped everything into APIs, the world of RAG, etc. But basically, that could be data, and that's, that is the data that is feeding into it, or maybe you are using it to make various decisions, etc. Now you end up with a set of responses, and you can validate those responses. Now, in effect, what you really need to think about with the testing framework is to start isolating things, and in this case, you could be, everything's static apart from the prompts, or maybe the LLM's been upgraded. We did actually run some of these between GPT-4 and GPT-5, and the results were dramatically different. You might be changing the data, and I'll show you a couple examples of that. And all of those means you can freeze things and test things in a little bit of isolation, which gives you some kind of structure. Okay, now just moving on a little bit, and you validate them, and it's either valid or not valid. Now, I'm just going to quickly show you kind of an example framework. Now, Harry's going to do live demo. I'm just going to record mine because there's kind of a lot of moving parts. Now, what we're basically going to be doing is we're going to be we synthetically created a bunch of data for Brooklyn, which is where I live most of the time. And within that, what we're going to do is we are going to look to buy companies within, this is basically local companies. We're going to analyze the finances for them, and then we're going to come up with LLM to decide what the best companies to buy are. Okay, so that's really kind of the problem. And all the data is kind of stored in JSON files. So if we just, just run that back. Let's start this little demo off. Now, so what we're starting off with here is basically a set of JSON files that we've generated. You can see that we've come in, we've got market data, and that market data, it's got a tail of, 1 month or 12 months or 24 months. We've got turnovers, etc. Now, what we tend to do is we take the structure, we bring it into our tool. Now, what we can also do is we convert the JSON structures into a database, and this I'll show you. I'll talk about why that's useful later. Now, all of these descriptions, we've actually used AI to, sorry, let me just go back and pause slightly on that one. Just go back slightly. The data here, we've actually used AI to document it, which is quite useful. Now, this is our little testing harness. And what we're going to be doing here, sorry, this is our generation. And what we're generating here are scenarios. So I want 1,000 New York sole proprietors, fast food, C Corps with a high turnover, reporting type, and an improving credit event. Fire that off, and that's going to generate me a bunch of data. Now, we also have a modeling engine which allows us to create various combinations of them. Now, you're going to see a lot of this with Harry's demo, and each one of these is a different variation. And what we actually did was we actually generated a rich set of variations where there's kind of an even spread of all the different combinations of characteristics of the data that we care about. Now, the next thing we do is we're looking for some data. Just pause this for 1 second. Now, what we've done here is when we actually ran the prompt, I think we're using ChatGPT for this one, we actually asked it for a methodology. And this is, again, one of the things you can do to kind of understand what's going on behind the scenes with the LLM. Now, having a methodology is very good. If you track the methodology and the reason that it came up with, then you can actually have some kind of stability. But what we also did was said, well, now we're happy with this methodology. What we're actually going to do is we're going to put those into the prompts. So we then adjusted the prompts and started to add in the order of importance is, and we've added in those, and then we've gone in and added in these things into the prompts themselves. So we've used those, and what we're going to do now is this is the version 3 prompt that we're running. Now what we're going to do is we're actually going to move on from that, and we're going to create an analysis, and that's going to go off, and we're going to run our pipeline. That's running that in the background. That's going to come up, and that's going to pick the top 5, which is great. And if we look over on the right-hand side, it'll actually given us a reason and a rationale as to why it chose those top 5. Okay, now carry on a little bit. Now, the next thing we want to do, just going to again pause slightly on this one, is that we've decided we don't particularly care about the turnover. If it's a low turnover business, it may be actually be something that we care about to purchase. Okay, so we're going to change our prompt. Now, if we see what we're going to do is we've actually added in a new line to the prompt. If we just go off and run this, and we'll copy this and we'll run this in the framework. Now, in this case, what we're going to do is we're going to compare the results with the original one that we just run, which did not include the which was using the turnover. So you'll see here that what we've actually got is that we've basically chosen 5 different businesses to purchase. And you can see that the reasoning is within that. And that's actually good, because that's actually shown us that we are on the right track, that the change that we made makes sense, and it's also given a reason associated with it. Now, the next thing we're going to look at is actually the effect of invalid and bad data. And I'll talk about this a bit later once we get into the world of data. Now, what we're actually doing here is that we have, a bunch of results that we've come back with. Now, what I've done is I've actually gone through and created some data for some other businesses, but I'm removing some of the data. So we're not tracking some of the data. Now, these are not included in the original results. So I know we're basically creating just chum in the water, something that's nothing to do with the results. They're very low profit, etc. So they shouldn't be picked up. And I'm just curious to see what the effect that will be upon our results. So if we run that, see, we just do the null there. So what we're doing is we're using prompt number 3. I'm using empty values, and I'm going to compare it with the original prompt 3, and we're going to run that off. And what you'll see there is we've still got the same 5, but you'll see that the rationale that it's used has actually changed. So the effect of the data, even though the data was not involved within the results here, it has actually changed the rationale. So as part of your testing, you need to kind of bear in mind the understanding of why it's making a decision, and then that should really give us pause then, because what's the effect of having bad data? should we be using bad data more thoroughly when we're actually missing data, etc., because that may well affect the results of the LLM. Now, moving on. Let's just go back to traditional development a little bit. Now we've moved out of, so far we've just covered the kind of the history of testing, and I've just kind of shown you a framework, and we're going to carry on with that a little bit, but we're going to take a little bit of a sidebar at the moment, and we're going to move off into kind of traditional development and how it works. So basically, in effect, you have your data, you have your requirements, and you have your expected results. Just checking, Mantis, can you still hear me? Everything moving along all fine?
Yeah, I can see you. Yeah,
that's fine. I was just sometimes talking into the void. So we have a data, requirements, and expected results, and in effect that gets handed off to the coder, and the coder then will code it. They'll have some actual results, and you'll have some comparison. Did it work? Did we actually get the correct results? Now there's a couple of little things here, so let's just talk about the requirements. Now, good old Humpty Dumpty said in a rather scornful tone, when I use a word, it means just what I choose it to mean, neither more nor less. Okay, so good old Humpty is basically bringing up the point that language is a wonderful medium, but it can mean pretty much, I think as we now know in the current world, can pretty much mean anything you want it to be. The other interesting point about the world that we live in, data, we really understand our data. Well, we sort of understand it. Well, most of the time we understand it. Well, let me check. Okay, so we're sitting basically on very sort of unstable ground with the use of language and our understanding of data. And if you think about how we move into LLM, those are really the two fundamental building blocks of what an LLM is. Okay, so now I'm going to hand over to Harry, who's going to spend a bit of time exploring the top part of this, which is how you build really, really good requirements. Okay, Harry, you okay?
Yeah, I'm unmuted. Do you mind just clicking onto the next? Yeah, if you just want to keep that slide up.
Oh, you want me to do that one for you? I thought you were going to...
just keep that slide up. I'll share my screen when I jump to the demo.
Okay, fine. Off you go.
Yeah, so requirements for us, right, they're integral to anything you do with model-based testing. So typically, most requirements are poor, right? We don't discuss them. People will tend to not be on the same page. And often many of the bugs that we run into and issues that arise when we're testing have come from some sort of miscommunication or misunderstanding, right? From various different members of your team as to how something should function, what those outcomes are. Things aren't really deterministic. So, in terms of what good requirements need, and Hugh will dig into this a bit more later, but, we need some sort of context, right? We need to understand what is our business terminology. We need a glossary of data structures. We need the metadata and the characteristics of those. And we need a sort of common set of grammatical rules that are consistent and managed with your own organization. And further from that, we need a way of getting everyone on the same page. Right, it's already common to have these miscommunications, and when it comes to testing large language models or agents that are assisting on them, that model is probabilistic, right? So if you have vague requirements and you're not being deterministic as to how you're testing them, you're going to end up with sort of inconsistent and misleading results, right? So what we have inside of our solution, and what I'm going to show you guys today, is how do we go about building up a common understanding and a model, right, that describes our requirements in an effective way, right, that can be used by all of our different users inside of our sort of development cycle, right, whether it's the programmer, the tester, the business analyst, right? We need to bridge the understanding between these roles so we can, solve we can translate our requirements essentially into something that is a deterministic, testable scenario. Okay, so this is something that we've been doing for years. Integral to model-based testing. I'm going to run you through a demo on how we do that, how we go through that cycle, and then what we're leading on to now is, hey, we're going to start applying this to testing our large language models and testing the agents that sit off them. Fantastic. So for this demo, what we're going to do is we're going to start with a textual requirement, right, of a promotional offer, which I'll share with you guys. We're going to create a model from that using one of our sort of AI agents that we develop ourselves. We then can adjust that model slightly, So we're business analysts, we're creating our user stories, we're defining how we want that system to work. And then we're going to adapt that same model as if we're a tester that's then inheriting that model to start enhancing it to sort of define our edge cases, our key boundary tests, all of those good validations, right, that we want to take place to ensure that our application, which in this case is our API, is functioning as we would hope. Okay, so I'm just going to quickly flash up this requirement here for you. Now, I don't expect you to read all of this, but essentially we, as this, this endpoint that we're testing as part of our API application is providing users of our bank with a promotional offer that they may qualify for. Now, the business rules behind this can be reasonably complex, but essentially they boil down to how long they've been at the bank, their age, their credit rating, and the type of account they have, right? And there's various verifications that would take place against that user when they go and try and see what offer they qualify for, and then they would get some sort of response back, right, as to what type of promotion they can get. So how we would go about building this initially in our solution is we would first of all use one of our accelerators to sort of go from this initially textual requirement into a nice model, right, which represents our system and is more deterministic and easier to understand as to the rules, right, and what validations are taking place within our system. So what we have here is we have our cloud portal, and there are various sort of importers here. You can see here we have a few AI ones, and the one that I'm going to use is our model GPT. So this is going to take a textual requirement. It's going to sorry, bear with me, I'm just going to get that requirement that I've copied here. So this is essentially just a textual description of that flyer that I just showed you. And what I'm going to do here is I'm just going to generate a model from that requirement. So it's taken this textual requirement, it's interpreted it using one of our AI agents. And what that does is it then goes and it builds us a starter model, right? Now, I appreciate we probably have a mixed audience here, so I'm not going to sort of go into too much depth with how model-based testing works, but I will sort of give you a high level. Essentially, the important things to understand here is we'll have some sort of start to our application. There'll then be various decision gates, validation, test steps, verifications that are taking place, right, as part of our in our application. And then there'll be various end states, right? So expected results. For example, you could qualify for the Golden Oldies promotion, Millennial Madness, loyalty bonus, etc., etc. So what this has done is it's interpreted our textual requirement and it's built us a starter model of all the logic and variations and validations that are going to take place, right, in the specific endpoint in our application. So now that I've got this initial model, what I would typically do is I'd come in as a business analyst or some sort of project owner, and I would make some small adjustments manually to add in more context. So what you'd end up with is a slightly more fuller model, right? Perhaps a bit more detail, some more notes. You may even be overlaying some specific data. And so you'll end up with a model that looks something like this. Now, what we have the ability to do, which is one of the key, sort of value points that we bring, is we have the ability to sort of start to generate different user stories and things that will eventually become test cases from this model. So as you sort of nicely pointed out earlier, all of these paths through our model, these represent unique user stories, right, that we're going to want to validate in some way. Okay, and they're nice, clear, they're unambiguous as to the logic of how I would end up in, with no promotion, or how I would end up with a loyalty bonus promotional offer qualified. So all of these different paths represent unique data combinations, right, and expected results that I should validate. Now, once that we've got this model, I can now pass this off to my programmers, for example, if they were going to implement this functionality, so they have an understanding of the logic that needs to be built. You can also start handing it off to your testers. And that's where we can really start building in some complexity with regards to our edge cases, boundary tests, and all those different unique combinations, including negative test cases, right, that we want to validate. So what we would end up with there is a sort of much more advanced model here. And all this is I've just essentially modeled out the equivalence classes and the variations that I really want to validate into a larger model. So you can see here, if I just sort of scroll down, we're checking things like how many years we've been at the bank, what the age of our user is, their credit rating. You know, I've assigned various synthetic functions, or data is being assigned in this model, right, that will then eventually populate our test cases, right, or any data that are associated to our scenarios. And we just have a nice full model here, essentially, of everything that a tester would care about when it comes to validating that our complex AI is API, in this case, functioning as it needs to be, right? And this same logic is applied to sort of. Oh, sorry, is there a question?
We've got a little question here. If you want to clarify, the question that comes from Rudolph is asking, when we're using the term model, are you meaning an LLM or the model that you're showing, right? If you want to just clarify.
Yeah, I should have clarified that. In this case, what I'm just showing you here is a model in our world. So this is a curiosity model that is describing some sort of application, not a large language model or, you know, agent that we might be testing somewhere.
It's kind of an enhanced business process model. We should,
exactly. It's like a BPMN style model, right? So now that we have this sort of full testing model, right, that has been adapted from our initial requirement model that was designed, we can go away and we can generate essentially our scenarios, right? All of the validations that we want to take place. So if I sort of click through these, you'll see that we have lots of different paths, right, that represent our test cases. If we look at this one here, the user's been at the bank for 1 to 4 years, for example. Their age over 65, they've got a low bank rating, high balance, gold account type, and our expected result is that they're going to qualify for the golden oldies promotion, right? So what I've built into this model is essentially some information about our API. I've got my API and all the information about that defined inside the portal here. I'm going to pass this API GET request into my automation scripts, and then I've got my expected results for this specific scenario defined. I've got 40 different scenarios here that have been generated from our optimizer, and based off the model that we built, I can now go and deterministically test all of these data variations, right, against this API. So I just simply come here, generate my code. It's also going to run the code. I can go away and really validate with certainty that my system is functioning correctly. So what we're doing, right, as a company is now we're applying this same logic that we've been doing for years to the testing of large language models and their agents, right? We want to be deterministic. We want to be certain that based off some data and combinations of variations that we're getting the expected results consistently that we want. And just to quickly finish off the demo, you can see here my test cases are running now. I can now pop back here into the portal. I can go and sort of view these. And what you'll see is we have our various different test cases. These have been executed, you know, based off all of those data variations and validations that we would expect. This is our GET request here. It's passing in all of the data for all of those different scenarios and then checking that we're getting the right assertions back. And this could be for anything, right? This could be for any sort of testing.
Yeah, so basically, if we're talking about this, so at the moment we're kind of pushing the data into the API, but the reality is when we're testing an LLM, if the LLM is using an API, so say for example our LLM was making a call out to this, in effect these are the virtual, every single one of these is a unique, different type of use case that the LLM needs to be able to handle. So previously, you know, we're focusing primarily on prompts and data, but actually in this particular case, what you actually want to be doing is freezing those and adjusting the APIs, which is in effect what we're doing here. So to be able to populate those, in effect, the test cases for each one of those would be the same prompt, but you would expect different results coming out of those prompts, whether you know, think of this as they got a credit rating of A+ or A-, and the results of that, you model those out, and those are the types of things, because you're making a request from your LLM into an API. So it makes absolute sense as well to surround your LLM which I'm going to focus on now, with all of the other much more rigorous methods that we're talking about to make sure that you absolutely know what that LLM is actually doing when it makes a request out to go and get data from some other place. What's in that data, and do you understand it? Okay, I'm just going to finish up slightly on that as well. So this is basically now, once you've got this stuff, in the tool, what we can also then do is move it back into the more traditional testing. Here I'm actually pushing it out into the TestRail product, or you could be putting it out into something like Zephyr or something like that, and you'll see that the data that has gone into it, so this would then be, when you get into your LLM testing, you've got to have some kind of control, you've got to be able to release it, and you've got to make sure that your regression tests are worked, and you need to put those into kind of a state-of-the-art system like something like TestRail, etc. So there's very much an integration point of bringing LLM into the more standard testing type scenarios. Okay, so that's where we kind of left off. We disappeared off into the wonderful world of requirements. Maybe if we have time in the questions and answer, Harry can actually talk a little bit more about his experience with going from a poor requirement to a good requirement. So traditional development, in a nutshell, you need to know what you have. You know what you want. You know how it did it, and you can check that it works. That's really what you want to do in traditional development, okay? The problem, this requires a systematic approach, it requires a clear and ambiguous requirement, and it needs a full understanding of data, and it also requires a testable system. So I think you can work it out based on my previous comments, that basically, generally unambiguous, not very systematic, a full understanding data just doesn't really exist, and testability is not really something that is fully baked into a lot of systems. Now let's move on to the world of LLM development, which is now actually, in many ways, much more challenging. Now you've got your data, you've got your requirements, and you've got your expected results. Okay. Now the requirements move into language. Now language are prompts, and prompts are written in language. And as we discussed earlier, it is extremely ambiguous. We may even do a whole practitioner's guide on language itself, because if you think about it, the LLM could be trying to work out, where you're from, and what kind of language you use. It might work out your educational attainment and decide, there's all sorts of things you need to worry about if you're using a prompt to be able to go off and search for your data. And then you get an actual result. Now, the real important thing, we talked about this idea of a glossary. Now, it's pretty rare to have, well, it's not pretty rare actually. There are business glossaries inside organizations, but those really need to be made available to the LLM so they can go off and actually start understanding. Like, I think the classic example of the word swap in finance, there's like 150 different meanings depending on the context of what actually a swap is. Now, there's also this concept of a known dictionary, a known data dictionary, and that really is very, very important. You are basically going to go and look at your data. So you really do need to understand what is in the data. You have your expected result, and as I mentioned before, there's the expected reason. It's pretty easy to add into prompts some kind of thing. Give me your reasoning, or give me the following information as well when we're actually producing the results that come out of an LLM. And you can then, once you've got those, you can then measure them and say, are these changing over time, and can set up alerts on top of them. Now, in effect, what you also need to do, if you think about testing anything, if you don't know what's on the left-hand side and you don't know what you wanted to do, how the hell are you going to know what the actual result's supposed to be? So the reality is you need to get into created data, or a very small set that you fully understood. You run your prompts, you get your actual results, and you get your actual reason, and then you're comparing them. Okay. Now, if you look at some of the white papers on RAG, etc., you have this thing called cross-verification. Now, cross-verification means that you actually have some external capability to verify that your results are actually coming out correctly. Now, one of the things that we do, when I quickly flash by the registering of the JSON structures, what we actually do there is we actually convert them into a database. So any structured, semi-structured data will end up actually inside a database. Now, it's no good for 10 billion rows, but it's very useful for testing because it allows us to run queries against the data that we've created that are also the same data that is then going into being used by the LLM. So this cross-verification process, really. So in a nutshell, the data and the requirements are intimately connected, and that's really what this is all about, really. Now, so I'm just going to quickly show you the other thing that we've been actually doing. It's actually quite fun. This where you design and build the prompts and data at the same time. So now in this particular example here, what we've done is we've actually, as Harry was alluding, we can actually generate code. So we're actually just generating the prompts, but we're also generating the data. So here you can see these are the prompts that we're incorporating into the model. So these are the standard prompts at the beginning, suggest the top local food, etc. And here's the data. Now that is the data that we plugged into our data generation engine, and we've got those like so. Now you'll see the little red markers. Those little red markers basically means those are negative. And what we're actually testing here is that the main prompt, which we're basically using here, should ignore everything apart from the single valid set of data that runs through it. And you can see that they're all negative apart from the point, all high prompt variables, which is the positive one, which runs right through the middle. Okay, so out of this, we can then basically just generate the prompts. So think of these as the different use case. Each use case is testing a set of prompts. There are 5 or 6 different things that we're actually playing around with in here. And what we're doing, each one of those may have just the turnover. It might not have the credit events. It might just have the trends. It might have the pattern. It might have three of them together. So it's got variations of them. What we're also then doing is actually generating the data that matches with that. So talking about what we were talking about before, having the left and the right, so you then know exactly what's going on. You can see we're creating high turnover, low credit events, and a positive EBITDA trend. Now, what you'll end up with then is we've also identified the results. We've actually put the test case name into the names of the companies, which is quite useful. It's quite a good technique to be able to say, well, did we find the right data rather than have to remember what they are? So the data that's generated, and if we go back into, that's our packs of data on the left-hand side. And then if we go and run it, what we're actually doing now is we're going to use all prompt variations, which is the data set that we just created, and we're going to use an analysis, and that's the prompt that we generated. And let's actually go in and see what it came up with. And give it a second to run. And what you'll see there is, sure enough, it's found that correctly. So we've actually tested against all of the negative scenarios to make sure that those don't come in, and actually we can just check the rationale at the same time. So using the modeling, you can actually use it in a kind of quite clever way to actually build the variations of the prompts and the back-end data as well at the same time. Okay, I'm now going to kind of pile into, into data in a kind of much more detailed way now. So data quality, data lineage, and privacy. Now these are kind of massive issues that we've got to worry about. Now, data often contains hidden, private, personal, and commercial information. Now, I'm going to talk about this a little bit later as well. But so what I'm talking about here is that quite often data isn't where you expect it to be. Now, once you've actually run a training set on that, you may well have leaked some personal data in there. You might have gone to the trouble of actually masking that, some of the core data, but actually you may have missed some stuff as well. So you really do need continuous and deep scanning to be able to make sure that nothing is leaking through into your LLM, because your LLM is actually being exposed to your developers, and your developers then can in effect have full access to production data, which is bad. Just because it's been turned into a token doesn't mean that it's masked. Okay, so it's really important to think about actually scanning that data to look for PII and commercial information. Now, the other thing that's very interesting, and while we've been working on this demo, we've actually been playing around with lots of bad data, just seeing how the LLM actually reacts. And it actually reacts very differently. We're dealing with bad data or unknown data. The little example where we put some nulls in there actually completely changed the reasoning for the entire results set. So now, what does that mean? In effect, what it means is that you have to actually tell the prompt engine to tell it what to do when it comes across bad or unknown data, so that you have some kind of consistency in terms of the kind of results that you're going to get. So, this is very much kind of a putting a much more rigorous set of prompts in there, so you've got total control of it. Now, I'm just going to pause slightly on that. The problem with that is, in effect, what you're doing is just writing code very quickly. You're not really using the power of the LLM. So from time to time, you need to turn all those prompts off, let it do its own thing, ask for the methodology, and make sure that you understand, oh, the new release has actually done a better job than we're doing, so maybe we need to rethink the prompts that we're putting through in it. So it's not just cast in stone. You need to be on top of this all the time. Now, the definition of bad data breaks down into inconsistent or evolving or broken data structures, especially now we live in the world of random JSON and XML and Avro and Parquet files, etc. Very often you might have had like an entity name had been misspelt for a couple of months and it's gone in there. So what's the LLM doing with it? We don't know unless you tell it. Okay, so inconsistent, evolving, or broken data structures. There are data errors in the system that have been introduced and not cleaned up. Very often you do have some bad data that kind of made it in. The effort of going back and cleaning it all out was just too much. They put in some balancing values into the general ledger, and they moved on and they left the bad data in the system. The other thing is, definition of bad data also can be it's good data. Now, the reason for that, or in fact, at the time it was good data, but it doesn't fit neatly into the now. And quite often, company will take over another company. It will import all of the historical data from the customers, but it obviously doesn't plumb directly into the new system. They've changed the way coding works, HIPAA 4010 to 5010, etc. So unless you know those old codes, then you really don't have a hope. So the LLM doesn't really know what to do with that. Okay. And also remember, whatever you're putting in now with your current sets of prompts, you've got to remember that that data is changing continuously and the now moves all the time. So a kind of rule of thumb, when testing LLMs, generate lots of broken data and evolve the prompts on how to handle bad and inconsistent data. Now, I'm going to talk about kind of the approach that we use. First thing you do is scan the basic structures. You discover the relationships, and out of that you can use our scanning tools, which will give you univariate results, core characteristics, and also a set of synthetic rules. It will also come up with a set of relationships between objects within the tool, and again, we're paying up a lot of technical debt. It's going to do the scanning, categorizing of privacy data and looking for commercially sensitive data as well. It can also scan and look for cross-technology relationships. I think that is probably the number one problem that we have now, is that data is, if we're talking about healthcare, you could have somewhere in the region of 20 systems involved in just processing a single claim, and you really do need to understand how those relationships go in, track across. You can use AI to document and group the data structures, and pointing at your local JIRAs, your local Confluence pages. Now you get into the concept of deep machine learning, which I'm going to talk about. Now you need to be clear about your training strategies that you need to use on them. I'll talk about those in a moment. Then you get your training data sets, which allows you to generate and mask data. Now, at this particular point, what we're actually saying is, when we get into the world of generating data using machine learning, what you're really focusing on is having the exact same characteristics that you have in production, but it is generated or biased data. And I'll come into the reasons for doing that. But in terms of the actual, this is the before and after of some of the data we're using on some of our development databases or testing databases. And you can see that they're actually the same, even though they have been synthetically generated. And these are some really, really powerful tools that you can use when it comes to testing LLMs. And I'll explain why later. Now, you've also got the functional data, which was kind of the data that Harry was generating in terms of creating all their API content, etc., which has high variety, because he had, I think, 38 or 36 different variations, payloads that would then be pushed into the API. Similarly with the LLM data that you're putting into my example. Then you basically have this idea of finding and making data on demand, or in some kind of framework shifting left. Now, what you end up with is, in effect, a corporate metadata dictionary of all of the data that you're dealing with. Brilliant. Doesn't really exist. In most companies, in other industries like it would be inconceivable to run the business without a dictionary of all of your kind of assets, whereas our assets are the data, we never track them. Now, obviously, once you have that dictionary, your AI and LLM can basically go to town on it. You can point it at it, and you're using all of the power of the scanning that you've already done, all of the business knowledge that's been put into it, and that's fantastic. AI has got a really strong footing to be able to work on it. Plus everyone else, everyone in the organization is interested in that. Okay, now let's just quickly, we're kind of running out of time here, so I'm going to go a bit quicker. Again, look at it later. Hallucination in neural networks are neural networks don't know about the facts. They learn patterns and relationships. When something is unseen or when the training data is ambiguous, it can confidently generate an answer that seems correct without basis in reality. Okay. Overfitting, it's too closely on a specific noisy data set. A noisy data set contains maybe some bad data or historical data which doesn't make any sense, and it doesn't learn the underlying principles. So again, these are the types of things that we need to worry about when we're talking about data. Lack of real world grounding, and that's just, it's just making simple mistakes. And actually, when we were building some of the prompts, it did make some fairly blunderous mistakes to start with. It did a pretty good job at the end. Primary reasons for bias in networks are it arises because only as good as the data they are trained on, okay, which is absolutely what you need to focus on, making sure that the data sets are extremely good and you fully understand them, okay. So in other words, if you have problems, it will actually amplify them. So a data set bias, it's trained on data, a specific subset of data, or one, you've picked one of your systems and you're trying to use that that training data set to basically train your entire LLM for your entire organization, but you could be looking at one specific market, for example. Algorithmic bias, this is again kind of the prompts. And we talked about that a little bit, about how you kind of enhance those prompts so you've really got a good understanding of them. You can also measure them when things change. You do an upgrade of something, either an API or you do an upgrade of the LLM itself, and you've got to go back to basics and make sure that everything you've done in the past still works. Now, they learn from massive diverse data sources. A rare medical petition with life, they might have never seen that before. So you've also got to think about black swans, things that are not happening, and be able to feed the LLM with potential things that are rare and expand those out so it can recognize them. And also, you're putting new features into your systems all the time. Your LLM needs to be trained on those before you build up a history of them. Otherwise, what's it going to do? Synthetic data, that's how you create them safely at scale. And what you really are talking about is train synthetic. Now, train synthetic, test real. This is basically a technique that machine learning algorithms use. They actually synthesize the data and then they test it to make sure that it matches with the original data, and that's what you'll see where you're doing some machine learning. You'll see that it's continually refining that and comparing it with the data. And this concept TSTR, you may have come across this before if you're deep into LLMs. Now, our approach is in effect kind of a three-pronged approach. So the stuff that we were talking about, which is basically this idea of modeling, enhancing data, and creating functional tests with potentially new functionality, and that's pretty much everything almost that Harry was showing you. That will feed into the training AI, whatever. I think there's the three major ones out there, plus you might be looking at bringing an in-house one into play. Now, that's the modeling type variation that you're talking about. Now, the other thing that you can think about when it comes to enhancing the data is to actually force in different patterns. And one of the things we're doing with with our company things, when we were dealing with food things, the costs do vary dramatically dependent on the time of year. So you can get into time series data as well. And in our generation capabilities, we've got all sorts of different distributions that you can push into the data to make sure that the AI can pick up those distributions and make the correct decisions based upon them. But you can only do that if you know you have them, because you've created them on the left-hand side. So think of this almost functional and development. Now, when you get into actually using your production data as a training data set, it runs for a long time. It's pretty large and unwieldy. It takes a long time to run. And also, the size of the models, to using the word model in the LLM sense, means that whenever you're trying to run your queries against them, it costs a lot of money because there are so many tokens that it's actually running against. And we've done this on 1 million rows compared to 5,000 rows, and the cost is actually extremely measurable. So you can actually save a ton of money there. Now, I'm just going to pop this up. I don't really have a lot of time to talk about it. One of the problems with using live trained data is that it's very easy to actually reverse engineer commercial and private information out of it. And the reason for that is if you know 1 or 2 pieces of information, you can actually reverse engineer back to the real person. So exposing live trained data to your development world it's fine if it's going through, almost like a production code, which is your production prompts, as opposed to just letting people develop against them. I always do it whenever I go into a live system, select star from salary, order by descending. And you can do that with a prompt, and that's telling me who's the highest paid person in the company. There's k-anonymity, I-diversity. There's a whole bunch of things to worry about. So we may do a separate thing on how to mask data in LLMs later on. Now, obviously, you've got machine learning algorithms. The ones that are particularly good for synthetic data to avoid the problems of very large training data sets are these CT-GAN, TVA, and Bayesian networks. And what we'll do is we'll actually generate the data into those using those. That create the training data sets. Those training data sets can then be used to generate various data. And what we have then is masked data. So we can overlay our masking when we generate that data. Now, that's then going to go into the training AI. The training AI itself, by the way, will itself use machine learning. It sits on top of it. So it will take the data that you're feeding to it, but you've synthetically created. You can age it. One of the issues you've got with very large ones that it becomes out of date. It's small, but it's fundamentally based on production characteristics. You can obviously bias it if you want to, and there's ways that you can actually train the data sets to be biased as well to predict almost the same stuff as you're doing in the functional testing as well. Now, let's just run this while this is running. So this is just basically one of our Docker images, and we're generating some synthetic data, and we're applying some masking rules to it. And I think we're creating 10,000 rows from about a 10 million database that we were creating. Now, the way that our engine works is that it's basically all controlled with images. The training can actually run for an awfully long time. If you want to run your training for a week, great, but you're going to need a really sizable Docker image to do that. Now, in terms of kind of some of the secret sauce that we add to it, obviously we've got consistent masking so that when you generate the data matches, and also the synthetic generation. We've got tons of generation functions as well, which we overlay on top of that as well. So coming to the end as we've actually run over. So build a plan, do the research, prototype, build models of expected behavior, and this is business process models. Use AI to help. It's brilliant at helping, and it's been a massive boon to the world of data in that it allows you to understand data in a much more structured way and pay off tons of technical debt. The plan needs to evolve. First contact with the enemy, change it, add in structure and tools, add in measurement, comparison, and observability. Observability, and testability is the biggest thing you can take away from this. Automate everything, even unit tests, which is kind of what we were doing with our little framework there. And LLMs are all about the data, etc. So how can we help? I'm just going to basically, this is the advert for us. There you go, put that in for a bit of fun. So a comprehensive dictionary of all data structures and relationships documented using AI, deep learning, so we can run the deep learning on your data sources. Cross-system discovery and validation of data, which is this understanding the data in terms of the quality, powerful requirements and modeling, which is basically what Harry did. And hopefully, Harry basically talks about the fact that it probably takes 2 or 3 goes to actually get the model pretty close. But then when you get a group of people in a room together, think about a sprint room, you're actually going to basically come to a common understanding of what your requirements are, synthetic and masking routines, and then our pipeline tool, which is our own RPA tool. So that RPA testing framework took about an hour to set up, by the way. So that kind of gives you that. So that's kind of how we can help, and obviously very keen to talk to you guys. So what we've actually we've covered a ton of stuff today. We've run over as expected. what we're also going to do is we're going to follow up with this. Now, we're doing a bunch of things. We're actually coming up with a set of practitioner guides, and we're also interested to know from you guys what you'd actually like to hear more about. So I've just put down 5 of them at the top there. Requirements modeling. Do you want some more information on that? Deep learning, CT-GANs, etc. We can really go to town on that if you want. LLM privacy problems, I think, is a serious issue. I'm constantly being bombarded with Instagram posts from people saying they've managed to reverse engineer stuff out of their LLMs. Advanced LLM frameworks, how you build one, how you put it together, and what you should look for in it, and then also this idea of kind of an AI development strategy. So if you, I'm really serious here. If you guys could just email me or Harry, there will be some follow-up generally from the company, but we're really interested to know which ones you want us to work on next. We're also producing a bunch of practitioner guides as well, with how to use, what to look out, what to, etc., etc. So if you want to just contact me directly. I'm genuinely interested in, there's a lot of people came to this webinar today, so there's a very mixed audience. So what we need to know with our products, with our ideas, with our methodologies is where do we go and what do you guys need, and we will put the shoulder to the wheel and crack on and try and produce all this good stuff for you. Questions and discussions. Over to you, Mantis. I'm going to have you stop sharing. Yeah, and I need a drink, aka a cup of tea now. So.
I know, yeah, we're running over, so I will just share the slide again. Although we are running over, I will get you to answer a couple of questions, if possible, and then we'll wrap it up. So I did see Harry did respond to an answer in the Q&A, which is great, but we do have another here, which is for you, Hugh. We talk a lot about test data or data in general, but how long would it take to pay off technical debt? And can AI help you do that when it comes to test data or data in general?
I would say about a year ago, technical debt was the #1 problem with IT, in that people didn't really know what they had, and it was a serious problem in that you couldn't really go, especially, think of a challenger bank. A challenger bank can come along, it's got greenfield, it can come out with a product, magic. You've got all the old banks going, what the hell, we've got all these old systems, what do we do? AI is massive to help you pay off that technical debt. We've run, obviously we have a load of scanning tools which will tell you lots about the data, but in conjunction with AI, which can actually then go through and actually document the system, can do some specific deeper scanning. If you tie that in with some of the machine learning scanning as well, it's very and also the data validation, it's very good to be able to build those dictionaries pretty quickly, and I'm talking probably in 2 to 4 weeks for a couple of your major systems to be able to pay off a lot of the technical debt. Now that gives you a very strong footing to be able to just go faster just for general development and also compete with your new challenger banks, but also it's really kind of essential if you're going to rely on that data for your AI and LLMs.
Great, perfect, thank you, Hugh. And then one question for you, Harry, is if someone doesn't use modeling to build requirements,
business process modeling.
Yeah, but how can they get started? Can AI accelerate that process? In general, how do you see modeling as a starting point?
Sure. That's pretty typical in terms of where most organizations are, right? Is that requirements, even if they are sort of relying on like meetings and discussions, will be textual in some way. You do have some sort of modeling tools that are out there, but it does tend to still be a bit ambiguous, right? And the meetings are useful, but they can leave sort of different stakeholders with different interpretations, often interpretations, right, that they want to have of how things work. So that's where you can sort of get the miscommunication creeping in. The reason why we obviously do things from the model-based approach is just to remove that ambiguity. So, we're trying to get deterministic outcomes, right? We're trying to get sort of traceability, and you're trying to get some sort of clarity, right? So requirements in a structured, testable way, and everyone's seeing the same thing. So, AI can help you all over the place with accelerating in terms of like designing your requirements and understanding them. I think the GAMP analysis, it could certainly be useful, right? If you have textual requirements and so let's say you're not using model-based testing, certainly the AI is exceptional for like gap analysis and picking up on ambiguities and questioning if you've considered certain scenarios. So, and that's obviously some of the agents that we've built into our solution as well do that. So yeah, I think there's a lot you can do without model-based testing, but as we've sort of shown today, that this is the approach that we go for.
Perfect. Thank you, Harry. Cool. So I think, it's time to wrap it up. We have overrun, but as Hugh mentioned, there are a number of ways you can reach us. You can email Harry or Hugh or message them on LinkedIn. They're both super keen to talk test data or testing or AI, LLM. So feel free to reach out and get them in a call. Additionally, you can visit the Curiosity website to learn more about our platforms and solutions. You can also follow Curiosity on LinkedIn to stay up to date with all of our latest updates. And of course, all the links, slides, and the recording will be shared in a follow-up email tomorrow. So I think all that remains to be said is huge thank you for everyone for joining, and a massive thank you for Hugh and Harry for presenting today. Thank you, everyone, and see you next time.
Yeah, thanks, everyone. Nice to see you all. Cheers, then.
Cheers, guys.
Bye.
Bye.